Okay. Now we are about to talk about the reciprocals of the trigonometric ratios. All right. First of all, let me recap. We learned about the trigonometric ratio. Three trigonometric ratios: the sine, the cos, and the tan. Okay, and those are actually the trigonometric functions. Okay, sine, cos, and tan, and then also their ratio. Now, we learned about the formulas. So now we say that sine of the angle is given by okay, maybe before I start saying that, I want to give you an acronym to remember that, to remember the formulas. It's called the SOHCAHTOA. So it's like this, the SOHCAHTOA. It sounds like Japanese, I guess, not French, Japanese, yes. SOHCAHTOA. SOHCAHTOA. So use that to remember. The meaning is what? So SOH means like sine of the angle theta, that's S for sine, is equal to opposite side over hypotenuse. As I said, the opposite side is referred to Y, and then hypotenuse is like R, and then the K is cos of the angle theta is equal to A, is adjacent over hypotenuse, and then usually adjacent side is referred to X, and then the hypotenuse R, and finally the TOA, okay, is like tan of the angle is given is opposite over adjacent, and then as we said, opposite is usually referred to, excuse me, opposite is usually referred to Y, and then the adjacent side is X. So one way you can remember to the formula here is to say SOHCAHTOA. This is like not Chinese really, but sounds like Japanese. I don't know what can be in Japanese, but sounds like Japanese. Now, we're going to talk now about the reciprocals of the trigonometric ratio. Okay, reciprocal means the inverse. Okay, it's like if, let me give you an example. If, for instance, I have 2, a number like 2, I say the reciprocal of 2 is what? -2, right? No, -2 is the opposite of 2, but the reciprocal is 1 over 2. Okay, if I have a number like 3, for instance, its reciprocal would be 1 over 3. And then if I have a, let's say A, for instance, the reciprocal of A would be 1 over A. What if I have now something like A over B? What is the reciprocal of A over B? It's going to be, yes, you are right, it's going to be 1 over A over B, okay? But this is like a lot of writing. Remember the rule in math that says whenever a fraction of another fraction is like taking the first fraction multiplied by the inverse of, let me write it over here because of space. I said if you have like a over B, of course I agree with you, it's like 1 over, it's going to be 1 over A over B, okay? But you know, this will be written like 1 multiplied by B over A, okay? And then this is like 1 times B, it's going to be like B over A. So in short, you notice that in cases like that, we simply switch, okay, the numerator with the denominator of the fraction. So the reciprocal of A over B is just B over A, okay? The reciprocal of 2 over 3 is just 3 over 2, okay? The reciprocal of -1/2 would be -2 over 1, which is 2, -2, okay? So this is briefly what is about the reciprocal. Now, let's now talk about the reciprocal of these trig functions. So now, we have what we call sec of the angle is the reciprocal of sine. It's like 1 over sine, okay? Similarly, sine is 1 over sec. And then we have another one we call, no, didn't say it correctly here. It's not 1 over, it's cosec, sorry. Cosec, okay? Cosec is like 1 over sine. of the angle, and then sec is 1 over cos of the angle, and then cot. I think cot is the abbreviation, but it must be cotangent, if I'm not mistaken. But we call it cot, okay? Cot of the angle would be 1 over 10 is the reciprocal of 10. So I guess if you know this, we can answer the following question. This part is not that much it's not huge, okay, it's not a lot of work. Basically, the most important things to learn here is to know the reciprocal, okay, the meaning of it and how to calculate that. Now let's dive into exercises. Okay, I'll move this over here. Um, let's start with doing exercise number A. Okay. The question says, refer to the diagram alongside to answer the following question. State the following. Okay. For question 1, for instance, I will talk about sec A. I know that sec is the reciprocal of cos. So because cos is adjacent over hypotenuse, I will just reverse that order. Okay, I will say it's hypotenuse over adjacent, or it's r over x. So now I look here. I'll say sec of A. I look, where's my angle A? Angle A is over there. Sec is the reciprocal of cos. Cos is adjacent over hypotenuse. Now it's going to be hypotenuse over adjacent. So it's going to be equal to 5 over 3. Okay. Question 2 would be cot of A. We know that cot of A, cot is the reciprocal of 10. 10 is opposite over adjacent. Okay. Now the TOA, remember, TOA opposite tangent equal opposite over adjacent. So now, because the reciprocal, we're just gonna switch. Okay, the denominator of the numerator. So this is gonna be 3 over 4 instead of 4 over 3. And then number 3, we have like cosec. Cosec, which is cosec of A, which is the reciprocal of sine. Sine is opposite over hypotenuse. Now we're gonna say hypotenuse over opposite, so it's gonna be like 5 over 4. Now question 4 will be let's say cot of C. Now the angle is no longer A, the angle of reference is no longer A, but it's now C. Cot of C, we know that cot is the reciprocal of 10. So now we know that 10 is opposite because 3 is opposite C. Okay, opposite over adjacent, the TOA, okay? Opposite over adjacent, but now because it is the reciprocal, we're going to switch, we're gonna make it adjacent over opposite. So it's gonna be 4 over 3, be 4 over 3, and then 5, what we have, cosec of C. Cosec is the reciprocal of sine. Okay, sine is opposite over hypotenuse, so opposite is 3 over hypotenuse. But now we're going to switch that. It's going to be hypotenuse over opposite, so it's going to be like 5 over 3. And then 6, what we have, sec of C. Sec of C. Sec is the reciprocal of cos, so it's going to be like, we know that cos is cos the car in the SOHCAHTOA TOA, it's adjacent. Adjacent is 4 over hypotenuse, so it's going to be hypotenuse over adjacent, so 5 over 4. It'll be 5 over 4. Okay. Okay. Now we're going to do question B. And I'll move this a little bit like that. And then question B. The question says that refer to the diagram alongside and then answer the questions below. States the following. Okay, now question 1. move there by 1. What we have? Sine of theta. So now theta is over there, and then sine of theta. Sine is, you remember the SOHCAHTOA? The SO S is opposite over hypotenuse. So opposite theta is that, and then hypotenuse is the longer side. That's hypotenuse, so it's gonna be K over G. Sorry, K over G. And then question 2, we have like cot of theta. Cot is the reciprocal of 10, so 10 is opposite over adjacent, but because it's reciprocal, we can switch. It's gonna be adjacent over hypotenuse, so it's gonna be J over K. And then 3, we have like sec of theta. Sec is the reciprocal of cos. Cos is adjacent over hypotenuse, so it's going to be hypotenuse over adjacent. It's going to be G over J. And then 4, what we have cosec over alpha. Now the angle of reference is no longer theta, but it's now alpha. Cosec is the reciprocal of sine. So sine is adjacent over hypotenuse. So it's going to be G over K. 5. 10 alpha. 10 alpha is going to be opposite over adjacent. So it's going to be K over J. K over J. And then 6, cos alpha. Cos alpha is just cos is the car in the SOHCAHTOA, so adjacent over hypotenuse, so it's going to be K over G. Thank you. Now we're going to do question C. The question says evaluate the following without using a calculator. So now you can draw the triangle here. Okay, draw 2 triangles here. If you remember, as we did in one of the video, right angle triangle. Okay, right angle triangle. 1 here, and then that's going to be the square root of 2. There is going to be 45, and there also 45 degrees. And then another right angle triangle there. There's going to be 2, there's going to be 1, and there's going to be like root 3. And there it's a 60 degrees there, and 30 degrees there. Of course, it's a right angle triangle. Or you can also do the other thing I showed you is like 1. You write 0, starts from 0. Write 0, 1, 2, 3, 4. Okay. And then I'm just trying to find the value of special angles. Now we're going to square root all these values, square root the values, and then we are going to divide all this by 2. And then it gives us values like 0.5, root 2 over 2, root 3 over 2, and then 1. So those are the values of the special angles. If it is for sine, for instance, the sines will be like 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So that's for the sine. And then for the cos, it will be in reverse order. It will be like so 0 degrees there, 30 degrees there, 45 degrees there, 60 degrees, and then 90 degrees. So that for cos. Now, we can use this information to answer the question. So now, when I have like cosec of 60 degrees, I need to find what it is. If, for instance, I want to use my technique here, I know cosec is the inverse of sine. I'll look here, 60 degrees is √3/2. So cosec will be 2/√3. Okay, so number one, cosec of 60 degrees will be equal to 2/√3. Or if I want to use the triangles, 60 degrees there, sine is opposite over hypotenuse. Okay, so it's going to be hypotenuse over opposite, 2/√3. Can be like that, or we can do 2, let's say sec of 60 degrees. Sec is the inverse of cos. So cos, if I look at the triangle, for instance, cos is going to be like cos is 1, is going to be adjacent over hypotenuse, so 1/2, and then the inverse is going to be 2/1. Or I can look here, cos of 60 degrees there is 1/2, the inverse is 2/1, which is just 2. So over here the answer is just 2. Question 3 says a cot of 45 degrees. I look 45 degrees. I can look there. Cot is the inverse of 10, okay? And a 10 of 45 degrees is just 1 because it's opposite over adjacent. 1/1 is 1, and the inverse of 1 is just 1. So this remains 1. Question 4, cot of 60 degrees. So I can look here. Cot is opposite, okay, over adjacent. So √3/1. Then the inverse will be 1/√3. Okay, so it'll be 1/√3. You can rationalize this also. Okay, 5 will be say sec squared of 45 degrees. So 45 sec, you know, it's gonna be like 1. Sec is the inverse of cos, so adjacent over hypotenuse. So adjacent over hypotenuse, 1/√2. Now it's gonna be then, because it is the inverse of cos, it's gonna be √2/1. So it's gonna be like √2/1 all to the power of 2, which is just 2, because the power of 2 will cancel the roots. And the answer will be that. And then 6 says what? 2 cosec squared of 45 degrees will be, 45 degrees. Cosec is the inverse of sine. So sine is, so it's going to be like 1/√2. Or look here, √2/2, and then the inverse. So it's going to be, let me write it like this. I can use either the diagram here or what I wrote there. I prefer to go over here. It's going to be like this 2 multiplied by, it's going to be 2 multiplied by cosec is the inverse of sine. So it's going to be like 2/√2 to the power of 2. Okay. And then I know this will make, let me just write it over here. This is going to be 2 multiplied by 4, because the power of 2 to the power of 2 is 4, and then √2 to the power of 2 is 2, and then the answer will be 4, because we can simplify this 2 and that 2. That was 6, and then 7 says 7 says cot 30 degrees multiplied by 10 30 degrees. Now, cot is the inverse of 10. Okay, so here I can make my calculation easier. Instead of just find the value, I know that it's going to be like 1/10 30. Okay, multiplied by 10 is 10 30 also. 10 30 is like it is over 1 there. Now we can just simplify 1030 and 1030 there. And the answer, whatever we're going to do, is going to be 1. So you can check either by using the diagram or using the table I placed here, you're going to get the value of 1 there. Okay, and then 8, it's cot 30 degrees plus tan 30 degrees. Cot 30 degrees plus tan 30 degrees. So cot is like 1 over tan 30 plus tan 30 degrees over 1. So I can simplify this. If I want to write the same denominator, I'll times here by 1030. I'll times there also by 1030. Okay, you know, to make the denominator common, so it's going to be like 1 over 1030 degrees plus 10 squared. Okay, doesn't make 2 tens. Okay, it's 10 squared 30 degrees. Okay, all over 10 30 degrees. Now that the denominator are common, we can just add the numerators, and then they form like 1 plus 10 squared 30 degrees over 10 30 degrees. Now we can substitute. It's going to be 1 plus 10 of 30 is 10 of 30 degrees. You know, even if I look at this one, it's going to be 1 over root 3. So to the power of 2, it's going to be 1 over 3 all over 1 over root 3. So 1 plus 1 over 3 makes 4 over 3 over 1 over root 3. And then we can simplify this. That makes 4 over 3 multiplied by root 3 over 1, which means 4 root 3 over 3. You may get this answer, 4 over root 3. Note that the two answers here are identical. The difference is like one is rationalized, the other is not. Okay, if you get this answer, don't say you get it wrong, you still get it right. Okay, and then we have like cosec 30 multiplied by cosec 45. Nine square root of cosec 30 degrees multiplied by cosec 45. Now cosec is the inverse of sine. So sine 30 is going to be, it's like square root of a half, okay, multiplied by root 2 over 2. Okay, so this is the same thing as it's like square root of 1 over square root of 2 multiplied by square root of 2 over 2. Then there we can simplify root 2 and root 2, and the square root of 1 is just 1, so it's going to be a half. Okay. Now we can do the next question. We can do question D. Question D says evaluate the following rounded off to 2 decimal values. So I won't really gonna do that because this is the work of a calculator. So we can skip question D. Okay, but just remember, just write it the way it is. Okay, just the way it is presented in the calculator, and then press equal, and then you're gonna get the answer. Okay, so I will move to question E. We can do question E. question E says, without using a calculator, solve the following equations if the angles are acute. So in this case, for instance, in question 1, we will divide both sides by √3, okay? By √3, and this will be cosec of x will be equal to 2 over √3. Remember that cosec is the inverse of cosec is the inverse of sine. I can transform this. I can write it sine. This means that sine x will be equal to √3 over 2. Okay, because cosec is the inverse of sine. And then I know that we have √3 over 2. If I use the triangle or the table I draw, this implies that x equal to 60 degrees. Okay, and then sec x equal to 2. Over here, we know that sec is the opposite of, is the inverse of cos. So it's going to be like cos x will be equal to 1/2. Okay, and cos to 1/2, this means that x equal to 60 degrees. Okay, you can check the calculator. Cos of 60 degrees equal to 1/2. So and then cot x equal to √3. This means that 10x equal to 1 over √3. And then this means that x equal to 30 degrees. Okay. You may start by drawing the triangle or listing the table as I showed in question in the previous questions, then substitute the values as we did here. Thank you.